I can't believe we made it to the final lesson of chapter 5. So we're going to graph on the coordinate plane. Last time we were just looking at coordinates and reflections. Now we're actually going to do the graphing. Before we get started, I thought I'd show you some cute faces. Aww. Some of them are scary though, so watch out. That one's pretty cute. Look at that. Now seriously, look at those cheeks. That was my brother. This is the face I have about a new brother. Crazy. Slip and slide. Wow, that's just unexplainable. Yeah, that was at band camp. Look at all the snow. And I'm going to end, oh, look at that. Lost my teeth. I'm going to end with this scary picture. That is also my brother, and I have no idea why that happened, but it's awesome. Okay, so that was the scrapbook. It's done now. Let's go to the last lesson. Graph on the coordinate plane. Maria hid the clues to a scavenger hunt for her hiking club. Use the map to show where she hid the clues. Identify the location of each clue. All right, the first clue is hidden near a tree. What ordered pair describes its location? So the tree, what is this? 4, 2. Maria hid the next clue at a location reflected across the y-axis. So tree, jump across the y-axis. That would be the library. She walks 3 blocks east and 2 blocks north to place the next clue. Where is it hidden? Now look, if you go 3 blocks east, if you jump here and go up 2, you're like, whoa, nothing's there. That's because each little square represents 2 blocks. So she goes how many blocks east? 1, 2, 3, and 2 blocks north. 1, 2, and that puts her at the soccer field. The next clue is at a location reflected across the x-axis. So we're here, we have to jump over the x-axis. That puts us at the playground. Ooh, will there be treasure at the end? Maria hid the next clue under a rock by the lake. How many blocks east did she walk? Now remember, each little block is worth, each little square is worth 2 blocks. So 1, 2, 3, 4, 5, 6. And then the final clue tells the hikers to walk 5 blocks north and 3 blocks east to find the prize. What ordered pair describes the location of the prize? So 5 blocks north, 3 blocks east, and we were just at the lake. 5 blocks north, 1, 2, 3, 4, 5. 3 blocks east, 1, 2, 3. So that would be 8, 1. All right, 8, 1. Let's do some graphing. We have page 404, graph ordered pairs, and page 405 is graphing the reflections. So before we start graphing, let's go over some tips. Tip number 1 is always start at the origin. And move in order X, then Y. So if you start at the origin and you move the X direction first, then you move the Y direction, you should end up in the right spot. So 2 is going to be, for X, move left or right for X. Then I guess this would be number 3. Move up or down for Y. So the X value takes you either positive to the right, negative to the left, and then the Y value positive up, negative down. Let's do this. To graph an ordered pair, draw a dot at the point that corresponds to the coordinates. So graph point M at -3, 5. -3, 5. So you start at the origin. The x-coordinate's -3, so 3 to the left. The y-coordinate's 5, so 5 up. And it's +5. That's your dot. Graph a point N at -2.5, -3.5. So you start at the origin. You move 2.5 units left because it's negative. -2.5. Then you move 3.5 units down because it's -3.5. And then you plot that point N. Notice it's halves, so we went between the 2 and the 3, between the 3 and the 4. Now here are 4 points for us to plot. Try plotting -2, 4. That would be where you put P. So I'm looking -2, +4. Start at the origin. -2, +4. That's P. All right, try Q. 0 and -4. Start at the origin. Stay at 0. Then go down -4. That would be Q. All right, now we have halves here. So start at the origin. -1/2. And then -2 and 2/2. So that gives you R. And S, 4.5 and then 1. So positive. So we go to the right 4.5 and up 1. And that's S. So now we're going to try to graph reflections of our points across the X and Y axis. When we graph a reflection, we label it with this little symbol right here. It says use the notation to label the reflection of point A. So this symbolizes a reflected point. So it's just like a little apostrophe. You can graph points that are reflected across the X and Y axes. Remember that points reflected across the x-axis will have the same x-coordinates and their y-coordinates will be opposites. Points reflected across the y-axis will have the same y-coordinates and their x-coordinates will be opposites. So this was the tip from lesson 6. This makes me happy. It's a happy tip. When I get scared, I look back at it. Okay, so graph A, 2, -4, then graph its reflection across the x-axis. So you start at the origin. You go 2 to the right, -4, so it's down. That's point A. Now, to reflect across the x-axis, keep the same x-coordinate 2 and take the opposite of the y-coordinate. So we're jumping across the x-axis. And so that's going to be 2, 4. Because 4 is the opposite of -4. So point A, reflected across the x-axis, we have that little apostrophe, is 2, 4. Now, here's another one. Graph B, -1.5, 3, and then graph its reflection across the y-axis. So B, -1.5, 3 is here. We're going to jump across the y-axis. So to reflect across the y-axis, you keep the same y-coordinate 3, and do the opposite of x. So -1.5 becomes 1.5. Let's try this. Graph C, -1.5, then its reflection across the x-axis. So -1, +5. And that's C. Now we're taking C, we're jumping across the x-axis. So the x-axis jump is -1, so you keep that x value the same, and then -5, so here it is, -1, -5, used to be -1, +5, but you have the opposite for the y value when you jump across the x-axis. So D is 2 and then 3.5. They're both positive numbers. This is going to be D, 2 and 3.5. And we need to reflect across the y-axis. So we're jumping over the y-axis. So that's going to be -2 and then 3.5. Make sure you put the little apostrophe, -2, 3.5, so that x coordinate got the opposite. Let's look at the last example on the next page. Example 5. Mr. Martin is using a coordinate plane to design a logo. He graphs points at 2, 4, 2, negative 2. He reflects 2, negative 2 across the y-axis. Then he reflects the new point across the x-axis. What figure is Mr. Martin using for his logo? So, he started off by graphing 2, 4, right here, and 2, negative 2, right here. He reflects 2, negative 2 across the y-axis. Then he reflects that across the x-axis, and when you connect all these lines, it makes a trapezoid. This says Mrs. Shaw is drawing a map of the school. Her room is at negative 3, 4, and the gym is at 3, 4. The library is a reflection of 3, 4 across the x-axis. This point is reflected across the y-axis to graph the y-axis to graph the office. What figure is graphed on the map? So let's start here. Her room is at negative 3, positive 4. So that's her room. The gym is at 3, 4, both positives. The library is a reflection of 3, 4 across this x-axis. So let's jump over the x-axis, 3, negative 4. And this point is reflected across the y-axis to graph the office. So we're going to go to negative 3, negative 4. And what is this figure? So look at that right there. Well, it's not really a square because these sides are a little longer, so that would make it a rectangle. Let's do some more practice in the guided practice with a partner. All right, make sure you partner up for this. And it's super short. It's just one right here. It says use a coordinate plane to represent Jasmine's stone garden. Graph points E and F, then reflect E across the y-axis, F across the x-axis. What's the shape of her garden? So go ahead and do that one and see if you get the same shape that I do. So I'm graphing negative 1, negative 4. Oh, negative 1, negative 4, that'd be down here. That's E. F is negative 3.5, positive 4. And then reflect point E across the y-axis. So E is going to jump across the y-axis right here. And then reflect point F across the x-axis. So that's going to be negative 3.5, negative 4. And what's the shape of this? Well, I guess these are all in a row. This is here. This is here. So that looks like a triangle to me. Okay, let's do the independent practice. For the independent practice, we're doing number 1 through 12. So let's just get all of these circled. All right, so for these first ones, you're graphing and labeling each point on the plane, so label the letters. And then here you're graphing the point U, B, and R and their reflection. And then this one, Amelia drew a map. You're going to reflect the points and draw the points and then say what shape it is. Do it. Let's check the independent practice. I'm going to go ahead and zoom in here. In quadrant 1, we have D and S. T is at the origin. In quadrant 2, we have K. F is here on the x-axis. In quadrant 3, we have A. N is here on the y-axis. And then L is in quadrant 4. Down here, we've got U in quadrant 1 and 4. U is in 4, and the reflection of U is in 1. The R's here, sorry, that's supposed to be right on the blue line. So R is in quadrant 2, and the reflection of R is in quadrant 1. B is in quadrant 2, the reflection of B is in quadrant 3. And then down here with Amelia, she started here, It reflected across the y-axis, then it reflected across the x-axis, and it made a triangle, which I didn't write triangle yet, so I will. All right, let's do the reflection. I can graph on the coordinate plane. When graphing the ordered pair x, y, I must start at 0, 0, which is called the blank. Next, I move, what is it? Left or right, up or down to find the x coordinate. Finally, I move left or right, up or down to find the y coordinate. Graph and label each point on the coordinate plane, so A, B, and C. And then when reflecting an ordered pair across the x-axis, the x or y value stays the same and the x or y value is opposite. When reflecting an ordered pair across the y-axis, which one stays the same and which one is opposite? On the coordinate plane above, graph and label the following points with this little apostrophe symbol. Reflect A across the y-axis, B across the y-axis, and C across the x-axis. So do that up here on this coordinate plane. And you're done.